Hey everyone, welcome to lesson 2.2. We're going to take a look at the axis of symmetry, vertex, and step pattern. So identifying these characteristics of parabolas will help us be able to graph them. So let's review a couple of things. The axis of symmetry is an imaginary line that cuts the parabola in two equal sides. Since it's a vertical line, the equation of the axis of symmetry is x equals a. The vertex of a parabola is the point at which the parabola changes direction. And since it's a point, it has to have coordinates of x and y. Now the step pattern. The step pattern describes how points move in the y direction as one step is taken in the x direction. So the step pattern changes depending on the coefficient of the x squared term. So let's take a look at our parent function. Now, I wanted you to be very familiar with the parent function so we know the basic coordinates to the shape of the parent function. So for y equals x squared, -2 results in a y value of 4, -1 gives me a y value of 1, 0 gives me a y value of 0, +1 gives me a y value of 1, +2 gives me a y value of 4. So I'm going to go ahead and plot those points on this set of axes here, 0, 0, 1, 1, 2, 4, -2, 4, and -1, 1. So this forms the basic parabola, the parent function, y equals x squared. Now let's talk about the step pattern. Let me change my color here and we're going to zoom in. So the step pattern refers to how the y changes when we move in the x direction. So if I start at the vertex and I move over 1, we can see that my y value goes up by 1. On the next change, if I move over 1, then my step goes up 1, 2, 3. Now we don't really have any more room here. But for the parent function, if I take one more step over, my y value changes by 5. So the very basic step pattern for the parent function is 1, 3, 5. Now again, as stated above, this step pattern changes according to the coefficient of the x squared term. So let's take a look at a different example. What if I want to graph y equals 2x squared plus 2? Let's use that table of values. Let's do some substitution. So y is equal to 2 times -2 squared plus 2. In this case, y equals 10. And we plug in -1, 2 times -1 squared plus 2. That'll give me 4. If I plug in 0, y equals 2 times 0 squared plus 2, that equals 2. I'm moving right along, y equals 2 times 1 squared plus 2, that'll give me 4. And then finally, y equals 2 times 2 squared plus 2, and that will give me 10. So let's go back to our graph and we'll put those points on our axes here. So let's start with the vertex, which looks like it's 0, 2, and then 1, 4, and 2 and 10. -1, 4, -2, 10. So do my best here to put a parabola through these points. Okay. Now let's zoom in and let's take a look at the step pattern here. If I start at the vertex and I move over 1, we see that my first step is actually 2 in this situation. If I move over again by 1 unit on the x-axis, if I were to count up, looks like it's 1, 2, 3, 4, 5, and 6. So let's consider our original step pattern was 1, 3, 5. This step pattern looks like it's 2, 6, and maybe you can guess what's missing there. So if we take a look, how is this linked to the a value or the coefficient in front of the x squared term? In this example, that coefficient is 2. So does that make sense to you? The coefficient of the x squared term in this example is 2. And what happened to our step pattern? It started as 1, 3, 5, but now for this example, it is 2, 6, and the next number would be 10. So the step pattern for this function has been doubled, and that's because of the 2 in front of the x squared term. Okay, let's take a look at a different example. Here, the difference is the negative value in front of the x squared term. So in this situation, we would have -4, -1, 0, -1, -4. And the a right here, or the coefficient in front of the x squared term, is a -1. So let's go ahead and plot these points. We still have 0, 0. We have 1, -1, 2, -4, -1, -1, -2, -4. And what has happened here is it seems that our parabola is flipped upside down. So let's get in close here and take a look at the step pattern. If we go over 1, we come down -1. And if we go over 1 more, the change is a -3. If I go over 1 more, the change will be a -5. So let's compare this step pattern. Remember, the original step pattern for the parent function is 1, 3, and 5. And the step pattern for this particular example is -1, -3, and -5. And how does that happen? All the signs are changed based on the -1 that is in front of the x squared term. So hopefully with this lesson, you've reinforced the idea of the axis of symmetry, what the vertex is, and what the step pattern is, and how it changes depending on the coefficient of the x squared term. See you next time.